Good evening, everyone. I, Tanya from CosmicShala, welcome you all to today's webinar on knowing our universe with mathematics. I welcome our esteemed guest, Dr. Shibesh Kumar Pacif, Assistant Professor of, Senior Grade at Center for Cosmology and Science Popularization, SGT University, Gurugram. Sir has done his graduation from Sambalpur University, Odisha, and is currently serving as an assistant professor of senior grade at CCSP SGT University in Gurugram. He is a researcher, teacher, and science popularizer who completed his PhD in 2011 from Banaras Hindu University. He was awarded the NBHM Postdoctoral Fellowship in 2015. Was then involved in an outreach program of CTP Jamia Millia Islamia.
I am thankful to Ritik and Tanya and all their teams. And now we can start with our talk. So this is about how to understand the universe. Actually, this is infinite, and whatever we will know, that will acquire less than 1% always. Because whatever this is a saying by Einstein also, if we will go on knowing the universe, then it will blow up. For example, you can see there is a saying, if you want to grasp the Graham's number, your brain will collapse to a black hole. Similarly, if we will try to understand the universe, it is infinite. Okay, but it is we have to know whatever, because without knowing the universe, how it works, we cannot survive. For example, now we can talk here through video calling. This is the one of the what you can say, the application of general theory of relativity also. The communication system, the GPS system here, these are the application of general theory of relativity that we will discuss here. Okay, so let us start it. Shall we start?
Yes, sir.
Okay, so you can see here, as our here the topic is our knowing our universe with mathematics. Why mathematics? Because to my understanding, and also many knowledgeable people, they say mathematics is the language of the universe. Any other languages, for example, English, Hindi, French, German, whatever the language we know, these are invented just to communicate. But the mathematics is the language, it is already in the universe and we have discovered it. Okay, this is discovered. Mathematics is discovered, but all other languages are invented. You know the difference. So let us try to understand the universe with some simple mathematics. Okay, and about me, our Tanya has told about you. I am Dr. Shibesh Kumar, and I have a great deal of interest to popularize science, to speak, and to provide all the basic information about our universe, about our existence, about how all these natural phenomena works to the general public. So this is my interest, and I am working on this. So here you can see the outline of my talk is just we will try to understand what is how to see the mathematics in the nature. There is just a fun here I will share, and then observable universe, then cosmology. Cosmology is the study of the universe with mathematics. Okay, so here I will explain something about the creation myths, then our what is modern cosmology, Big Bang theory. I hope all of you have heard this about this Big Bang theory. Okay, then I will explain the general theory of relativity. This is our mathematics. From the general theory of relativity, we will start with the mathematics. Okay, then here modeling our physical universe. Here actually the modeling is our physical universe. Okay, and then some mathematical models I will explain with some mathematical tools. Then I will explain the dark energy model. I hope all of you have heard about the term dark energy. Okay, so here we can see, can we move this somewhere else? Here we can see here, as you can see this picture, very simple picture. Here you can see, if we start our journey from the earth here, then we can see our sun, then we go move away, and here we can see, we'll see some stars, Procyon we can see in our cluster, in a constellation. Then here the nearest star Proxima Centauri, and when we go away, then we can somewhere we can see our Milky Way galaxy, and when we go away, then we can reach here. This our cosmic wave. Okay, and here you can see what element we are made up of. Generally, as I was explaining just before some time, that if somebody asks you who are you, then generally common people speak his name, I am XYZ, and his or her limit is up to maximum my country or my religion. And all these are actually only socio-economic definitions. Either I am rich or poor, or this and that, that is whatever. Socio-economic definitions we don't, we know only, because this is taught to us. And this is the one of the falsehood. This is one of the lie we are living. Because for example, India will win all the country, and all the country collectively will be India. Then there will be no country, isn't it? So these are some changes. So we cannot say these are the socio-economic definitions are a lie, we can say. What is the actual definition? Yes, we can say, for example, who are you? Somebody say, I am a structure in the universe, which is made up of some chemical elements. You can see our 65% oxygen, 18% carbon. Then here you can see hydrogen, some 10 or 11%. Then all other elements collectively, our 100% this element. And all these elements are made up of, you can say, atoms. You can see behind me there is a symbol. This is our center, CCSP. So here you can see all these atoms are made up of electron, proton, neutron. Here you can see which are made of quarks. And when we go, then according to string theory, we can say these are strings. So these are our, we can say. So according to this is our scientific definition. Then when we go beyond it, then we can discover the whole universe. We are actually the whole universe. Okay. So in this way, we can understand. So the universe, what is the universe? All of the space, time, whatever we can feel in through our five senses and beyond it, everything collectively is called our universe. But these are our physical universe. Why? Why we can say? Because we can understand this through some logic, through mathematics, through our physical understanding, our senses. This is our physical universe. Beyond this, we can also discuss about that. I'm not discussing, as you have seen in our some mythological structures. We can discuss something else. I'm not going there. Okay, just physical universe we'll discuss and how to model it. Okay, now the question is, where did all these atoms, molecules, starting from the you can say atoms, molecules, quarks, the galaxies, how this came to exist, where all this came from, and how all this works, and what are the fundamental building blocks of the universe? These are the basic questions we are asking since our human civilizations around, we can say, some lakhs of years, around 2 lakhs years, we can see, 2 to 4 lakhs years our human civilization is there. And now recently some people, some scientists are claiming that around 4 to 8 lakhs. Okay, but still we can see these are the whole history we are searching. But the literature, if we will find out, then the oldest literature we will find out around 6,000 years before Christ, that is in India and in China. we can get it. So that is why India and China are they were actually the oldest civilizations. We cannot say because there may be something else also we may discover, but this is as of now we can understand. Okay, so here you can see this kind of fact. So mathematics is not about calculating things, it's about understanding the operations of nature, observable universe. How to understand the universe. Now, what is observable universe and what is entire universe? This is very important to understand when we are trying to understand the universe with mathematics. You see here, seeing far is seeing past. For example, you see the sun. The sun now at the exact time, for example 4:10, you see the sun. So the sun is actually 8 minutes old sun you see. And when you see the pole star, actually you see the pole star before 450 years ago. Okay, that means the light when started its journey in 1655 approximately, then that light is coming to you now and you can see the pole star. Okay, so seeing far is seeing past. So in this way, when we see here, we will see, okay, but the universe is expanding. This is proof that I will show you how universe is expanding. Not only expanding, it is accelerating. Okay, and the cause is due to dark energy. So this, with this calculation, when we will calculate, then we can say our the whole total here you can see universe is around 93 billion light years. It is comprising of 93 billion light years. Okay, so now you can see from, for example, now this is the earth, you are standing here, this is a galaxy A and a galaxy B. So you can see the light coming from this galaxy 13.7 billion years earlier here. So you can see this light here. Also you can see light coming from here to here. That means for this person, for you, for me, two galaxies, galaxy A and galaxy B are existing. But a person standing here in galaxy B do not know whether galaxy A exists or not, because the light from here cannot reach here. Okay, so that means here we can see this in this way. With this calculation, we can say our universe is 93 billion light years. So this is about here our observable universe, but the entire universe. So there is no age, no boundary of the universe. It is expanding every second. Some million kilometer. It is expanding some million or billion kilometers with the physical universe. Okay, so now the study of the origin, when the universe started or when the universe came to exist, how it evolved through different stages, how the structures came to exist. Now your body structure, my body structure, or the structure of this earth, structure of this whatever we can see, when they came to exist and how all this works. So here we can see our modern cosmology and speculative cosmology. We can see there is a our creation myth. But the problem is that you can see what is modern cosmology. Modern cosmology is, we can see, not only it is only from Galileo, Copernicus, Newton. Before this also, before 2000, 3000, 4000 years ago also, some people always there, they were actually trying to understand the universe with logic. They didn't have such kind of mathematical tools, but they were trying to understand through observation, through logic, through meditation, through something, some instrument they were using. Okay, so those all are scientists. Okay, so those were doing modern cosmology, but behind them some people were there always. Now also you can see how their this creation myth or speculative cosmology is used just to exploit people. Okay, there is no science, nothing behind it. Only fear and greed is based in creation myths. I will explain it. So modern cosmology, generally we can say it is Galileo and our Copernicus, Newton, and our modern means our Albert Einstein, we can say. Okay, after this, whatever we are doing, these are modern cosmology. These are based on observation, what we see, what we can experiment, what we can find some mathematics, not or earth centric. So he was sent to jail. So these are the problems. At least now also people are how they are facing troubles. Just now you can say to one of my relative, I told that like our sun, there are many, all the stars are sun. And then the old lady argued with me and told that according to our this only one Surya Bhagwan is there only. I'm saying all stars are sun. How is it possible? I explained, but nothing entered into her head. Okay, so how can I? So you see, this is the actual modern cosmology and the creation myths. These are based on religious, culture, traditional, which have no science, nothing there. But nowadays, people are trying to explain all these things through science, which are some argument are there, but leave that, we are not doing that. So this is also this kind of thing. Why I try to discuss, because here also many students maybe they were thinking that Brahma has somebody staying above the clouds and doing all this magic and all these things. No, we should not think like that. Okay, so all these are our creation myths. If you see here, there are more than 300 creation myths. There are more than 300 creation myths are there in our on this earth, many part of the. When you go to Africa and tell them about the Lord Shiva, then they don't know what is it. Now, for example, you go to Africa, for example, you go to Middle East, or somebody here from the, you can see in Africa, in Zululand, Unkululu, this is their creation myth. They have different god, different structures, different kind of books, their holy books. Now you see everybody here. So all of them have some various faiths, various. They also try to prove. For instance, Sumerians, they have recorded history of 4,000 years. You know about Sumerians? Sumerians, about their that Nile River. They have 4,000 years recorded history, and they can relate a lot of things. When you go to Chorki creation myth, okay, then in India, Hiranyagarbha creation, we believe it. Then Sankhya Yoga theory, Buddhist cosmology, Jainism cosmology, a lot of myths are there. Okay, we should not believe on them. Yeah, there may be some arguments, there are some logical things also. We just understand them and don't go and try to fight with them. Neither there are some people, they will bring their revolver, okay, and shoot you. What you are saying, you are talking against our faith. What you are saying, your science, take your science with you. Okay, so don't argue. I am also facing a lot of trouble. Some people are trying to hit me, but that is why I stopped talking to that star. All these concepts are there here, everywhere. Okay, not only here. So these kind of things are there. And once I was giving a talk in Lucknow, one person came and told, "Sir, where is that Golok Dham?" I don't know, brother, that what is that Golok Dham is. I don't have any idea. If we'll see through a telescope, we'll see, and we'll go up to 13 meters. This is the center of the universe. And there are a lot of myths are there. So here you can see, here some people try to explain it. You see these people, Copernicus, and here Kepler law of planetary motion. You know this in physics you have studied. Newton, the greatest one, he discussed the some mathematics. He invented the calculus and explained it. So this is the force of gravitation and how two bodies interact. Okay, so he gave this, and these are all our mathematical tools. So these are the part of modern cosmology. So what is modern cosmology? Modern cosmology is based on mathematics. It is a mathematical physics subject. Use of mathematics, use of logic, use of some assumptions are there, still there, but they are logical. Okay, based on some observation, based on some experiment, we can use some mathematics and try to understand the universe. This is our modern cosmology. Okay, there is no only arguments, no beliefs, no imagination. Okay, so here you can see here the most dominating force is our gravity. You see here gravity is the, how many forces you know? There are four fundamental forces. One is weak nuclear force, strong nuclear force, electromagnetic force, and gravity, gravitational force. Okay, out of these four forces, gravity is the weakest but long range force. Okay, this range is infinite. So gravity is the most dominating force in the universe. Okay, and if you understand the gravity properly, you can understand the universe more and more. If you have seen the movie Interstellar, anyone who have seen the movie Interstellar? So if you
Yes.
try to understand the movie Interstellar, then you can understand something about gravity. Okay, and the gravity in the classical regime is well described by general theory of relativity given by Albert Einstein. So if you try to understand the relativity, first read something. We can search some better theory. So science, the beauty of science is that it is not fixed. It cannot say that you have to obey this, neither will kill you. Okay, but this is the creation myths. These are the religious people whose new theory, Sing Sang theory, for example. That Sing Sang theory, which can explain better than Big Bang theory, then that theory will be accepted by the community. So this is the beauty of science. Okay, so that is why I am always in favor of science, because it is a changing process. Okay, you're getting me, everybody? What is mathematics, what is science, what is the beauty of science? Okay, so let us discuss about the Big Bang theory. So just I told you this structure, everybody seen this in the internet. When you search about Big Bang theory, you will get this picture. Okay, you are here. Okay, here in this W map is a Wilkinson microwave anisotropy probe. This is an experiment started in just 20 years before. So this is mapping the universe. This space instrument is there, sent by the NASA scientist or European scientist also. So this is mapping the universe. This is seeing the past and mapping the universe. So for example, that person who has asked me, where is the Golok Dham? When you see with this past and you go, you will see some galaxies. First you will see Andromeda galaxy, then other galaxy, and you will go past, and when you see this is a maximum, here you can see this one. This is called the baby universe, or this is the cosmic microwave background radiation. That means this is the radiation left over by the Big Bang. Okay, so this Big Bang, what happened? And many people ask, what is before Big Bang? There is nothing like before, because the space and time, all the concepts are the concept of the Big Bang. Okay, before there nothing exists. But before that, what happened? Around 10 to the power minus 43 second here. Then we do not know that. Okay, so here you can see, when we see the past, we see the baby universe here, and these are theoretical here. This portion here you can see theoretical and mathematical only, not observed here. Okay, this portion. Okay, so around 4 lakhs years after the Big Bang, we can see the cosmic microwave background here, and before this 4 lakhs year, we don't know exactly. All these are theoretical. Okay, not observational. So observation is from here. Okay, here all these are observed. Okay, so here you can see various stages, just like a child. When a child takes birth, when a child is in the womb, just a zygote, it expands very rapidly, very rapidly. In 9 months, in just to 70 days to 80 days, it will take a structure of a baby. Okay, then when from the womb the baby come out, after that you see how fast the baby grow till the age 18, 19, 18, 19 years. The growth is very fast. After that, growth halts, isn't it? And then live the rest of the life. Similarly, here you can see when we go backward here, you see this. You can say this is the womb. We do not know before the womb. Okay. So here you can see this is the womb, and when the baby come out from the womb here, you can see and grows very fast. Okay, and then it is getting older. Okay, similar just like our baby, the universe. This is a baby universe, and this is the matured universe. And what will be in the future, we'll see. Okay, so I will show you through mathematics here some equations. You can see this is the dark energy domination. Means here universe start to accelerate. The expansion here you can see expansion is very fast from here to here. You can see this stage is called the inflationary phase. Inflationary means the expansion is very fast here. Okay, in the tiny seconds here, this expands to very fast, big universe. Then it is this is decelerating phase of the universe, means acceleration. Here this acceleration stops and deceleration started here. Gravity dominates here, so structure formation. But now dark energy. Okay. So here you can see now you have a very clear idea about what is the physical universe and what is creation myth. What is the physical universe and observable universe, entire universe, how the observable universe came to exist, the theory explaining it. It is the best theory till now is Big Bang theory. Then that Big Bang theory, how this Big Bang theory is, we can try to understand. The more about you want to understand, you have to read some books. Okay, okay. But before that, even all the mythical stories, if you find, they are discussing about a static universe. Means some creator is there somewhere, created the universe. That's it. Okay, even Albert Einstein, he was also convinced with a static universe, and he was thinking, and he invented cosmological constant, a constant added to his field equations just to find a static solution. Okay, but Edwin Hubble, a great scientist, he in his name there is a Hubble Space Telescope. You know, Hubble Space Telescope stage, it will go to expand maximum size of the universe. For example, a balloon. For example, you blow a balloon, it will go on expanding. Then certain stage, it will go on decreasing, or it will blast. Okay, similarly here you can see this is the universe expanding, maximum size it will reach. Then it will, when gravity dominates, if the gravity dominates, then it will go on collapsing, and this is called the collapsing universe. This is a big bang, this is called the big crunch. Okay, and here this is called the critical universe, means this will go on expanding, and in some far future it will collapse. Okay, this is called the critical universe. So both these two are the decelerating expansion of the universe. Okay, and here this is called the coasting universe recently. That means the universe don't have any acceleration, no deceleration, but it will expand forever. Okay, this is our another called universe, called coasting universe. Okay, and this is our accelerating expansion of the universe here, Big Bang. And this is the present stage. It will go on expanding, and at certain stage, everything rip apart. You see here, all the galaxies are together. Then some distance, then more distance. Then a stage will come when galaxy will separate out, stars will separate out, atoms will separate out, nothing. So one electron will be here and another electron will be there. That means in your body, which is a collection of some trillion and trillions of atoms, one atom is here and another atom will be in Andromeda galaxy. Okay, so that is called the, so here you can see, so this is the present stage of the universe, this is the past of the universe. So this model is the one of the nicest model till now, according to which we will get the perfect age of the universe, and it will this explain the some data. Which kind of data I will show you. You know about supernova. Supernova is a actually type 1 supernova. That means some star, when the star are heavier enough, when they collapse, okay, under its own gravity, then it will the outer core burst up. This kind of star is called the supernova. Okay, so observing those supernova, we can collect some data. Okay, so our some of the experiments, they collected the data, supernova data in different galaxies. Okay, and they try to feed those data with these models here, all these models, this model, this model, this model, this model. So most of the models scientists are working now are either this 4 kind of model or any intermediate model also. Okay, they either they will get this kind of model or intermediate here, any one kind of model. This is the best fitting model here. Okay, so all these models, when you they try to fit with the data, this is the present time. Okay, this is the present time, and this is the past of the universe, this is the future of the universe. So when we fit this supernova data to this model, you see decelerating this one, this model, then this red line, you can see this is the recollapsing universe. Big Bang, this is the present time, and after this will increase up to maximum volume, then it will collapse. This is the recollapsing universe, this model. So this data only fitting recently, just recent part, means some supernova in our galaxy or just in Andromeda galaxy they can find, and they can see this model fitting this supernova data. And this model, this you can see this green line is critical universe, this model. So some few more supernova data they are fitting. Okay, then this model, it is fitting some more supernova. But this model is our you can see this orange line is the accelerating expansion of the universe. You can see far past here. You can see this supernova means far past means far. So you have understood the basic our universe, mathematical universe. So you see how this all these data are available. You can collect those. I will tell you how to do this also. If you want to write some paper also, you can contact me. Okay, so but you have to work, because I cannot work, because I have a lot of work. If you try to, if you ask me, I will tell you these are the references you can take, and I will tell you how to write papers on this. Okay, so you see, so how these are the basic things you understand. So these are the physically I try to explain it. Now mathematical things you try to understand. Okay, it will take few months, then you can start to do some work on this. Okay, so these are the things you can understand, and this is the expanding universe. How volume are they are getting separated. You see, some galaxies were here nearby, they are going away. You see, just like a balloon, you put some dot on a balloon and blow it. How they are going away from each other. That is the in that way our universe is expanding in all the directions. Okay, so now you see, so this theory, this Big Bang theory, according to this, here you can say Big Bang to Big Crunch or Big Rip or anything, whatever the future. All these here you see, these various stages of the universe here. Just I told you here, these are the various stages of the. This is first stage singularity, second stage inflation, third stage deceleration, then fourth stage here acceleration, then fifth stage is the future of the universe. Sorry, present phase, then sixth stage is the future. So you can make some mathematical model which can explain this thing better. Okay, or also if you have some better mathematics, better understanding, you can find some different model. Okay, so all these are based on general theory of relativity. Okay, which is based on the Riemannian geometry. What is Riemannian geometry? You would try to understand what is first. You have to understand what is scalar. Everybody knows. Then what is vector? Everybody knows. So beyond this, you can understand the tensor. Okay, when if you are good enough in vector calculus, then start to read about the tensor calculus. In the tensor calculus, you will understand these symbols. This is the Einstein tensor. This is the energy momentum tensor. This is the gravitational constant G, and this equation is called the Einstein field equation. Okay, so this is a complicated set of field equations. This part is explained by geometry. The geometry is explained by this part, and the matter part in the universe explained by T mu nu. So you see, the left hand side is geometry, right hand side is the matter. So mathematicians are more familiar with the geometry, and physicists are familiar with the matter. If both of them combinedly work, they can understand better. Okay, so according to this is the theory of relativity here. This theory of relativity can be explained in 6 sentences. Here you see time is the 4th dimension, because most of our creation myths, they have never discussed this time as a 4th dimension, but 3 spatial dimension and 4th dimension here. This is the first concept of the general theory of relativity. Light speed is constant around 3.3 into 10 to the power 18 meter per second. Then here you can see faster you move through space, slower you move through time. Then what is it is a black hole here. Time stops here, isn't it? You know about the black hole. Time stops near the horizon here. Okay. Then here, what is gravity? Gravity is just take a, for example, take a, for example, you say. So these are the successes of the general theory of relativity. So what theory told and what observations recently explained. So how beautiful the theory are, and how nice. Just how pure so or much karo. This kind of thought every people. This is the what you can say. Every people are doing that. In our family, even people are doing. So what we'll say. Anyway, so these are the basic mathematics behind the modern cosmology. And you see some more mathematics here. Even the right mathematics here, we can see this G mu nu is actually R mu nu. This is called the Ricci tensor, which describe the this R. You see, and the when you contract it with some mathematics, you do some mathematics, you will find this R, which shows the curvature of the curvature scalar of, in the universe. Okay, in the space time. So this geometry, all these things you can calculate it. This G mu nu, R mu nu, metric tensor, and this is the curvature scalar and geometry tensor. All these things you can calculate it through simple mathematical tools. You have to read something from the tensor calculus, okay, and try to understand what are these terms you can calculate for a metric. What is a metric? I will show you just in the next slide. So this left hand side is the mathematics, right hand side is the physics. Okay, so both mathematics and physics together you work. Nowadays, one more people needed, and those are actually this computer science, because computer scientists are, when you are expert in some the computer language, then it is better. Okay, so do some computational tools like Python, C++. Okay. So this is the line element. This line element means is the distance between 2 points. For example, in 2-dimensional, your Euclidean space, distance between 2 points, how do you measure it? ds square equal to dx square plus dy square, isn't it? You're getting me? Distance between 2 points in Euclidean space in 2 dimensions. So x and y axis is there. So ds square equal to dx square plus dy square. If it is in 3 dimensions, x axis, y axis, z axis. So ds square equal to dx square plus dy square plus dz square. Correct? When we take the time dimension, then you have to add one more. That is the minus dt square you have to add. Okay. So here you can see this is the coordinate system here. The line element you will take in this way. with some simple tensor calculus, you can calculate Rij. This gamma ijk, this is called the Christoffel symbols. These are the covariant derivatives. Okay, then you, this is the Christoffel symbols formula is here. This is the simple derivative here. Then this is the action principle, you know, energy momentum tensor here. So you take this metric, calculate all these, calculate the energy momentum tensor, and formulate the field equation. I will show you the field equation. Okay, so modeling the universe with this mathematics here. The solution of Einstein field equation is called the cosmological model. Okay, so Einstein field equations describing the cosmological dynamics are complicated, non-linear, ordinary differential equations. Now you see how simple mathematics is here. You have to start with geometry, then calculus, then differential equation. Okay, so these are, when you understand this, you can formulate the field equations. This is the metric you can take distance between 2 points in the 4 dimension. You see here distance between 2 points. Here you can see spherical polar coordinate system r, theta, phi. These are the 3 spatial dimension, and this, I'm sorry, this is the t here. This is the t. Some mistake here. T. So this is a minus dt square plus a square t is called the scale factor of the universe. Okay, you can say this will give you the radius of the universe. Okay, so here you can say d square equal to minus dt square plus a square t into dr square r d theta square plus n square theta d phi square, and this k is called the curvature scalar. According to the value of k, you can see flat geometry, curved geometry, or this kind of curved geometry that I will explain here. And here, all these here, we take the velocity of light as 1. Okay, just some mathematical calculation. Neither you have to take here c square dt square. This c you have to multiply here, c square dt square. This is with the time. Okay, and this is the spherical polar coordinate system. And with that simple mathematics here, you use all these mathematics here, or nowadays there are softwares, just you put this, write this metric in the software, it will calculate all the Christoffel symbols, resist tensor, resist scalar, metric tensor, Tij, everything it will calculate and give you the field equation directly. That also you can learn, but first learn the mathematical calculation in your hand, then go to software. Okay? So these are 2 field equations. They are actually in Einstein field equation. This equation give you 10 equations which you have to solve. It is very complicated. Okay, but certain symmetries, as we can assume the universe is homogeneous and isotropic, this assumption give you reduce the equation to only 2 equations. So just this 2 equation explain the whole universe, whole dynamics of the universe. Here h is called the Hubble parameter, a is the scale factor, rho is the density in the universe, and p is the pressure of the matter content in the universe. This left hand side you see, this is the geometry, and this right hand side rho and p, this is the your, you can say, matter part. Okay, this k is the curvature scalar. Okay, you see from these 2 equations you can also derive this equation called the continuity equation. I think in physics you have studied continuity equation here. Okay, and this equation is called the Rai-Choudhury equation or the acceleration equation. Okay, from this equation you can see here this a double dot, if a double dot is greater than 0 means it is accelerating. If a double dot is less than 0, it is decelerating. Yes or no? So this a double dot, you see, this a double dot is equal to minus of these terms. Here pi is positive, 4 is positive, 3 is positive, a is positive, g is positive, rho is positive, p is positive. So all these positive terms will give you a equal to, a is less than 0, means decelerating expansion of the universe. But our data is showing that universe is accelerating. Okay, so how to find the acceleration? That means either this theory is wrong or our data is wrong. Okay, so one possibility is there. If we have such kind of, for normal matter, for example, water or air or anything, this matter you take, all these matter, density is positive and pressure also positive there. But there are some kind of matter which has a negative pressure. For example, this pressure dominates. Pressure is negative and dominates the density. Then what you can see, this term will be negative and negative, negative, positive. In that case, you will get a 8 double dot greater than 0. Isn't it? So in that case, so this will give you the accelerating expansion of the universe with pressure negative. Okay, so this is very complicated thing that we'll try to understand this. Okay, so for a normal matter, you see here you see three kind of geometry we have. For k equal to 0, we have this kind of universe we will get. K equal to plus 1 means k equal to plus 1 means you see here positive curvature, this one. Okay, and this is the negative curvature here. What is positive curvature here? When you add the angle between in this triangle, add this angle, and this angle, it will be greater than 180 degree. Here less than 180 degree. Here the three angles summation will be here equal to 180 degree. So this is the flat geometry. This one is the flat geometry, hyperbolic geometry, spherical geometry, and this is explained by this. All these give you this kind of models, which is you can discuss with the critical density also. What is critical density? 3h square upon 8 pi g is known as the critical density. Okay, so all these output you can get it from these equations here. Okay, so these are all the geometry I have explained. Now let us go to the physics, because without physics everything is worthless. Now we have to explain the physics. Okay, so what is the physics behind it? Now you see. So to understand the physics, we have to discuss this matter part, density and pressure. Okay, let us discuss. So if we consider what kind of matter are there in the universe, we do not know. Either it is perfect fluid, imperfect fluid, a Chaplin gas type of fluid, or a van der Waals fluid, or dark energy, dark matter, whatever the things we do not know properly. Okay, so it is very complicated. So let us see. First, let us consider perfect fluid. Okay, so for the equation of state of the perfect fluid is P equal to W. Equation of state of a perfect fluid is P equal to W. Also, you see here, you have two equations and three variables. This A, rho, and P are the variables, and all are constants there. Okay, so two equations, three variables. Can you solve it? You cannot solve two equations, three variable. So you need one more equation. Let the equation be P equal to W rho, which is the equation of the barotropic perfect fluid. So with that, you can solve the field equation. You will get the 70% of the universe, not data, but theory. Okay, 70% of the universe volume is occupied by dark energy, 25% dark matter, 4% here you can see your free hydrogen and helium, and just here you can see 1% is here our all the star, galaxy, black hole, interstellar gas, everything. It is collectively just 1%, and out of which only 0.03% is this dark energy. Why it is dark? Because we do not know, so we have given its name dark. Okay, dark energy we do not know. The simplest is the cosmological constant. Albert Einstein has discovered this cosmological constant lambda to find the static solution. Then when Hubble found that the universe is expanding, Einstein told that I have done the biggest blunder in my life, that is the cosmological constant. But in 1998, when the scientists discovered that the universe is accelerating, they brought this lambda to the right hand side of the Einstein field equation, and this lambda is the best candidate for the dark person, Albert Einstein. Okay, So, but the cosmological constant is not the only possibility. Other possibilities are the scalar field models called the quintessence, phantoms, K-essence, Tachyon field, and also chameleons, Galileans, holographic energy, then Chaplygin gas, polytropic gas, van der Waals fluid, bulk viscous fluid. A lot of candidates are there to explain the accelerating expansion of the universe. This is an open question. You can work any of these. You feed your model with the data, and you can say, yes, this is my model. Okay. So with a cosmological constant, when you try to, I'm not doing all the calculations here, just saying with a cosmological constant, if you solve the Einstein field equation, this is the this lambda actually invented, introduced by Einstein in the left hand side, but right hand side we can add it as a candidate of dark energy and solve the field equation. Then we will get a solution which is the best fitting model here. You can see according to this, when you fit the supernova data, okay, here Z means here Z equal to 2. This is the past. Okay, this is the past. You see here past, it is coming to the present time. This is the Z equal to 0 means redshift Z is the present time here. Okay, Z equal to 0. So present time, you see all the model are fitting here, but when you go far and the distance go beyond, that means Z equal to around here, you can see 1.5 or 1.6. These two models, this red and blue line, these are the our perfect fit model here. You can see when no cosmological constant here, omega lambda equal to 0, omega m equal to 1 means perfect fit model. This blue line, this is not fitting well in the higher redshift. Means in the past, this is not fitting the model well. This one also we can see when you take the cosmological constant only and no matter, is also in the higher redshift not fitting. But you see this model when omega m equal to 0.31 and omega lambda equal to 0.69 means 69% dark energy and 31% the matter, dark matter and our baryonic matter. Then this is fitting well all the data you see. Getting this? So you can assume this cosmological constant model, this green line, is best fitting model. Also, this also you can explain this diagram, and all other data here you can see CMB, boomerang, maxima, galaxy clusters, and here supernova data, Hubble data, CMB data, baryon acoustic oscillation data. All these are actually combinedly saying that you can see this circle, small circle here is saying that 0.31% here our matter, cold dark matter, and 0.7% here you can see our dark energy. So this is the best fitting model as of now. Okay, so what the cosmological constant? There is some trouble called the cosmological constant problem. You can search in the Google also. What is cosmological constant problem? Okay, so then to avoid this, people have considered the scalar field model, and according to this scalar field model here, the field equation will change here, pressure will change as in this way. This is the density of the scalar field, and with this scalar field, the equation of state is this one. Okay, W phi equal to P phi by rho phi, when this V is the potential, phi dot square is the kinetic. When the potential dominates the kinetic energy, then you can see this term will be negligible, this term will be negligible, and W phi will become -1. And this is equivalent to the cosmological constant. So scalar field model is also now considered very good model, which is fitting very nicely to the data. I will explain one data here, scalar field model of my own model published in a journal. You can see that. Okay, so to solve these field equations, there are some techniques. One technique I use is called the model independent way or the cosmological parameterization. If you just Google it, parameterization, cosmological parameterization, you will find my papers, many papers. Okay, so here you see the left hand side, A is the geometrical parameter, H is the geometrical parameter, Q is the geometrical parameter. Rho, P, and W or omega, this is the equation of state parameter. These are called the physical parameters. you can parameterize any of these. That means you can take a time dependent function of any of these parameter, and you can solve the field equation. And when you solve the field equation, you will get some solution. Those solution is called the exact solution of the instant field equation. Then you can compare that with the data and find the values of the parameters. Here here you can show you. Here you see, this is the HT. This is my parameterization I have taken. With this parameterization, I have solved the instant field equation and found these kind of solutions. Many solutions. Here 12 solutions I have found. And when we plot, these are this is our in my one parameter. This parameterization covers many models. For example, the cosmological constant model, this one. This is the power law cosmology. This is another cosmology. Different cosmology we can find. And their deceleration parameter T versus Q I have plotted and found some model are accelerating, some model are decelerating, some model are acceleration to deceleration, some model are deceleration to acceleration. But best fitting model we can get it deceleration to acceleration at present time. Okay, so that kind of model I have found two models, M1 and M2. So these two models I have found, for which I have plotted the scale factor. Means this is the Big Bang. With the Big Bang they started and go on expanding, and for example this model is, and it will, with a big rip singularity it will collapse. M2 model, here you see, with a Big Bang, you can see how they are different here. This blue line you see how the universe expand and it go on decelerating, then accelerating, high acceleration. And here the same for this blue line for model M2, you see different how evolution you see. These are the evolution of the universe with time. Okay, similarly, but to understand a model, we have to convert all the parameters to Z, redshift Z, because redshift Z, it is easy to describe the observation part. So we convert them all the parameters, this T to Z, then H Hubble parameter to in terms of Z, and with some data. This HZ is called the Hubble data, SN supernova data, BAO is called the baryonic acoustic oscillation data. All these data combinedly we have taken HZ data, HZ plus SN, SN plus BAO, HZ plus SN plus BAO. All these data we have taken and constrain the parameter alpha and beta. This is the chi-square test we have taken, and this is the degree of freedom. You know, you have to learn this some statistics also. And here model M1 and M2, for this these values. Then for model M1, with this data I have found these values. For example, here for this combined data, this is the best fitting model. Combined data for model M1 alpha I got this, beta this. Okay, M2 beta alpha this, beta this value, and I have plotted them. You can see with the Hubble data, and this is the supernova data. You can see they are fitting well. Okay, and compare with the lambda CDM model, and these are called the contour plots. Means the best fitting value alpha varies from this black spot are called the best fitting values, and but the range you can see some range here. Okay, alpha and beta range, alpha and beta range. Yeah, this is the Z plus SN plus BAO. So this is the best fitting values of alpha and beta we can take around here. You can see for this model M1, for model M2, here I have found. Okay, and with those best fitting values, I have calculated the deceleration parameter. In the past decelerating expansion, this is the phase transition, then came here at present, this value is minus 0.56 something. Then this is acceleration entering into the super acceleration. In the far future, it will super accelerate, and the super acceleration means the data, that means the universe will collapse to a big rip singularity. Okay, here also model M2, this one. Okay, for them here in the various stages of the universe, I have found the value of Q. Initial value of Q, then present value of Q, then here final value of Q, then the transition time. Okay, a transition redshift it is called when Q equal to 0. for this for the different data sets, I have found the value of alpha and beta, and I have found all these values. You can do this also. Then we can check the behavior. This is called the state finder diagnostic, SR diagram, and this is called the ohm diagnostic. This is the jerk parameter also we can plot, and all these are saying something, giving information about the various stages of the universe. You can do that. Okay, I have used the Mathematica codes. You can use any other code. Okay. Similarly, here the density of the scalar field. Then this is the potential of the scalar field. This is the W phi. That means this is the equation state of the scalar field, and we can plot it. This is the past, present, future. Past, present, future. Here you can see here past, present, and future. All these we can calculate it, and we can just plot them. Okay, so these were so all the theoreticians, when they see the plot, they can understand what is the behavior of the universe in these models. For all these models here, we can calculate the age of the universe also. Here you can see for different, so the best fitting alpha and beta value, this one alpha and beta for model M1, we will get the age of the universe is 14.04 giga-year, means 14.04 billion years. For model M2, here alpha and beta is this, and we can find the age of the universe is 13.92. Okay, so we can say these models are also good models, but further investigation we need. There may be some problem also that we can rectify. Okay, so here you can see conclusion. In this way, different models you can obtain with different parameterization schemes. If you search my paper, just my name you can search, you will get a paper where all these things I have done. Then there I have in the past 40 years, the number of parameterization all over the world people have used, I have collected all those in a single paper. Okay, you can learn those parameterization schemes, and you can make your own model. Okay, so these are the, similarly in modified gravity also, you can use this technique to find the solution. Similarly here, I have considered the Friedman-Robertson geometry, Robertson-Walker space-time. You can also take the Bianchi space-times, and you can find the solution. And so these are the remarks here we can see. In this way, physical universe, you can explain from the cosmological myth to the modern cosmology, then with the relativity, Big Bang theory, then how to discuss the mathematics of the model, how to derive a model here, everything we have learned here. And all these are Hubble Space Telescope and WMAP and many experiment. They have given us data. With those data, we have checked our model, verified our model. So in this year, James Webb Telescope is going to launch after 5 to 6 years, when you will be in PhDs. Okay, then you will get more data, which you can get precision cosmology are better than us. Okay, so further research if you want to do, so there are 3 streams: physical cosmology, observational cosmology, quantum cosmology. For those who are very good at mathematics, they can go to quantum cosmology. Okay, observational cosmology, if you are very interested in observation, optics area, you are very good, you can use observational cosmology. Physical cosmology, if you are good at mathematics and physics both, then you can go through here. Okay, so these are the fundamental questions you can ask. How did our universe begin? How did what is the current state of the universe? What will be the future of the universe? So in different ways you can explain it. What is the dark energy? How does it evolve? What is the cosmological constant, or the other models you can take? Then here dark matter problem is there. Solving the Hubble tension, fatness problem, initial singularity problem, horizon problem, structure formation, gravitational lensing. These are various topics. You can search it, you can work any of these. Okay, just not to believe that somebody created the universe and you are like what people explain, your grandfather and grandmother explain. I am not going against them, but
How black holes are born and die?
yeah, black holes are, you see, there is a completely whole theory black hole physics, but simply no death, only transformation. Okay, huge cloud of interstellar gas, when they collapse under its gravity, they form a star. Okay, when the if it is a massive star, very massive star, when the hydrogen becomes helium, lithium, beryllium, boron, up to to a certain stage, the outer core is carbon, oxygen, and the inner core is ferrum. Okay, then the ferrum is very heavier element, it will collapse to gravity, and the outer core burst out. This with this burst, when it is a very massive star, it will form a black hole. It is, if it is a small star, it will form a neutron star. If it is a very small star, then it will be again become a planetary nebula. These are the different stages of the star. So a massive star.
All
Okay.
right, sir. Thank you, sir.
Okay.
So the next question is from Indir Chavla. How can I become an astronaut in India? What are the requirements and how can I fulfill them? How do you think the society can be aware about career scope in space science?
Yeah, first thing better here, forget about how the society will do, because if you can convince to your parents also, that is if a student try to understand the universe, then only you can convince them. Okay, if somebody is a Brahma has created, or that God or that Allah has created, and they believe and do all the things, how you so much karo. This kind of thoughts are always there, so don't go and convince them. You do by yourself in your stage, you study it, you study astronomy, astrophysics, specifically nowadays astronautics. There are some institutes in India also. You can just try to get a seat there. Okay, for that you need to very very strong in mathematics and physics, these two subjects. Okay, then simultaneously you have to be strong enough in nowadays you can see is you can see ISRO is there, and other institutes are there. There IIST is there, and many institutes. You can just Google it. Okay, and you just study there in 3-4 years, and astronautics. Okay, then you can reach to up to ISRO or up to NASA, because in India it is very difficult. Man-made mission is very difficult for the time being in India. In India, you can go and make some religious temples and mosques. All these things are very easy, but launching is
The next question is, why haven't we observed wormholes till now? Do they collapse too fast or are classified?
no, that wormhole theory is also actually not proven. First thing. Second thing, wormhole. Okay, this is not physical till it is not possible. For example, some people say black hole means this is proved. Okay, this means when a star collapse under its own gravity, it will become, that means for example, it's a space time. The space time, everything goes inside. Inside nothing, but that breaks the space time. So anything falls into it goes somewhere. We do not know, because we cannot enter into the black hole. But some people say the opposite side of the black hole may be another universe, that may be a white hole. Okay, and nothing can escape out from the black hole, then nothing can enter into a white hole, and a connection between the general relativity, then we can find the whole solution. But proving it is now up to now it is very difficult. Okay,
Okay.
next.
Next question is from Manash. He has asked, so we can say that in the inflationary period before the expansion happened, there was not any.
So you can see that the inflationary phase. Oh, okay. In the beginning, we do not know the candidate of dark energy. Okay. So one of the candidate we can say is the vacuum energy. That cosmological constant is actually vacuum energy. Okay, so that vacuum energy means vacuum means nothing. Okay, but nothing means that is not nothing. It is the ground state energy level. Okay, so that thing is there, and with the time in the inflationary period, nothing was there. Then matter created. Matter means that gravity, due to gravity, matter created. Dark energy is nowhere there. Okay, means a huge matter, only gravity was dominating. For example, you take the example at your home now. If you keep full of water, the whole room you fill with water, then there is pressure, na? Water pressure is there or not? Okay, so this is the matter is there, but nothing is there means anywhere you can move there. Getting this? So in this way, freely. Okay, in water you cannot move it freely. Okay, so in this way, we can say that dark energy was not there, but recently, just 4 to 5 billion years ago, this started dominating. Okay, but actually, when we say this, you need to study the. There is a paper of T. Padmanabhan. You can write it. T. Padmanabhan in 2003 or 4 he has written the weight of the vacuum. You can write down the weight of the vacuum. When you read that paper, around it is 80-90 pages. You can understand this very, very well. I hope so. Got it?
Yes, sir.
Yeah, you can write the weight of the vacuum by T. Padmanabhan. That paper is very nice paper.
Sir, my question is, as time stops near black holes, but we can explain and discover those, then why can't we explain what was before Big Bang, even without time?
No, you can say before Big Bang is nothing like Big Bang. Okay, according to the present theory, nothing beyond Big Bang there. Okay, Big Bang is the beginning, but recently Roger Penrose, he just given a theory, twister theory. According to him, actually Big Bang is actually not the beginning, but the end state of the previous universe. Okay, so if you try to understand that, so those kind of theories, then you can understand that Big Bang. Big Bang is actually mystery. Okay, black hole is also a mystery. Okay, what the picture of the black hole also we have found is the black hole horizon only, not the black hole. It is not possible. Okay, so these are speculations only there. So when you try to understand the this is called a singularity. When you try to understand the singularity, then you can understand the black hole. You can understand the Big Bang. Also, if you want to understand the beyond Big Bang is nothing there according to this theory. But when you go to other theory, then you have to be strong enough in mathematics. Okay, then you can understand the crystal theory and you can explain that. I hope so. Hope it is clear for you. Something? Hello?
Yes, sir.
Yeah.
Okay, so
Ne
unfortunately, we are running out of time. So we'll try to include your questions in the next webinar. Moving forward, on behalf of the entire organizing team, I, Tanya Adlakha, deem it a great honor and privilege to propose the vote of thanks on this occasion. First and foremost, we thank our esteemed guest, Dr. Shibesh Kumar, who, despite his busy schedule and commitments, agreed to grace this occasion and share.
Yes, sir. Thank you, sir, for
Thank you.
joining us and giving this wonderful presentation, this wonderful talk to all the young minds who might have learned a lot, who might have gotten inspired by your words and your presentation. Thank you again for joining us.
Yeah. If you want this presentation, I will share it. Okay.
Yes, sir. Actually, a lot of students have asked in the chat box to share the PDF. Just share the PDF
Yeah,
of
yeah,
the
sure,
PPT
sure.
to me.
Yeah,
and
yeah.
I will share.
Yeah, I will
it.
share it. Okay, no problem. I'll share it. Okay.
Okay, sir. Thank you, sir.
Okay.